Now alternating current lesson 16. Since we have derived RLC circuit, series RLC circuit in previous lessons, it will be very easy now to understand. Now we have only two components, a resistance and a capacitance, pure resistance capacitance connected in series across a source of alternating EMF. Alright. In lesson 13 in series LCR circuit, this is what we had derived. The total resistance offered by the circuit, if it has three elements LCR, the total resistance called impedance was given as R square plus XL minus X is square root of that. Now since we don't have an inductor, so the reactance provided by the inductor, that is XL, that is equal to omega L, has to be eliminated from here. XL has to be eliminated. So since it is not there, so here no inductor, therefore XL is omega L is equal to 0. Therefore your Z becomes, impedance becomes R square plus minus XC square root of that. So it's negative. Negative quantity, square of that becomes positive. So I am left with Z is equal to R square plus X square root of that. Now also in alternating current lesson 13, we had derived when there are three elements R, L and C, the tan phi, the phase angle between the voltage and current was XL minus XC over R. Here we don't have an inductor, only resistance and capacitor. So this part is removed, this XL part is removed, so minus XC over R, and XC is 1 by omega C. I'm taking the magnitude part of it now, so your tan phi is equal to this. So tan phi is equal to this. Okay, you can take the negative sign, it's alright. So tan phi is equal to 1 over omega RC. So if you know value of omega, value of R and C, omega is equal to 2 pi nu, for India nu is equal to 50. If you know the value of R and C and put it here, the value of phi can be found out. So alternately you can look at this diagram to do it in a different way. For the resistor, the current and voltage are in phase, and for a capacitor we know the current was ahead of the voltage, or same thing as saying the voltage was lagging behind the current by pi by 2. For both of them, direction of current remains same because they are in series. For this, the voltage across the resistor is this, voltage across the capacitor is lagging behind the current by pi by 2. These two figures I translate here. I translate to this diagram. Voltage across the resistor and voltage across the capacitor to this side, to the negative y-axis, to this side. So this represents VC, this represents your VR. So the resultant of this and this is this one, that is okay. So this is the angle by which it is lagging behind the current. The net EMF is lagging behind the current. So if you look at this triangle from here, tan phi is equal to AK over OA. Tan phi is equal to AK over OA, that is OC over OA, that is VC over VR. VC, current into resistance, across the capacitor, current into resistance, I naught cancel, so your tan phi is equal to minus XC over R. This is the capacitive reactance, that was 1 by omega C is equal to this, the minus sign I have kept here. Now, so tan phi becomes minus 1 by omega RC, so phi is equal to tan inverse of this. Now if you put this, if you find the tan inverse of this value, it will come out to be, so the value of phi is found out, and therefore the EMF lags behind the current by phi. If you put this value, phi will lie in this quadrant. In this quadrant, the current is this way. So therefore it will be negative, right? Okay, thank you.